Alrighty, checkpoint 27. So here is that first question. And it says that Greta is painting two different rectangular prisms, and the prisms have the following dimensions. So we have prism A and prism B. We want to know which prism has a greater surface area and what is the surface area. Okay, and notice that we have two different units here. We have some in inches and some in feet. We need to make sure that we are using inches because that is what the question's asking. Now, right off the bat, when I look at both of these numbers, prism B has larger numbers than prism A, right? 1.5 feet is bigger than 1 foot. And if I were to add these two sides, 12 and 12, so that means that 1.5 feet will make prism B bigger. So right off the bat, prism B is going to be my bigger prism. All I need to do now is figure out, well, what is the surface area? So with prism B, we have a box, a 3D box like this, and my units, or my length is 10, 2, and then 1.5. If we take 1.5 and multiply it by 12 to get that to turn into inches, I will get 18, which means that this side over here is 18. So when we're finding surface area, we need to find the area of each surface. So if I were to look at this front panel here, there is another panel on the very back that is the same exact area. So I would have 2 times 18 times 2, because that's base times height. Then let's look at this top panel here, as well as the bottom panel. So if this bottom side is 2, that means that this top side is also 2. And if this long side here is 10, that means this top side is also 10. So for that purple panel, I would have 2 times 10 times 2. And then last panel would be this front one and this back one. So this long side here is 10, and this side over here is 18, which means that this side here will also be 18. So I'm going to have 2 times 18 times 10. So all we have to do is multiply all these together and then add everything up. So 2 times 18 times 2, 2 times 10 times 2, 2 times 18 times 10, so 72 plus 40 plus 360 gets me 472. So prism B would be larger and it would have a surface area of 472 square inches. Alright, number 2. So for number 2, we have these two identical rectangles, and it says if one rectangle solid with dimensions of 6 by 10 or 6 by 6 by 10 millimeters is stacked on top of an identical rectangular solid so that the bottom of the top lines up perfectly with the top of the bottom of the box, what is the surface area of this new rectangular solid? So pretty much what this is saying is I'm taking a box and placing that box right on top, and I want to know what's my new surface area. So if I'm essentially going to be making this box taller, right? When I place this box on top, the width won't be changing, but it's going to get much taller. So the bottom of my box is going to stay 10. However, it's going to get much longer. Okay, so here's my box now. If half of my distance here is 6 and half of my distance up here is 6, when I place them on top of each other, it'll double itself, right? So 6 times 2 would give me 12, which means this new side length is going to be 12, and the length here will still be 6. So this is my new box. I now have a 10 by 6 by 12 box, and we want to know what is the surface area. So a trick when you are finding the surface area of boxes is you want to take each one of your numbers, multiply them together, and also multiply it by 2. So if I were to start with these two, 10 and 6, 2 times 10 times 6. Then let's move on to 6 times 12, 2 times 6 times 12, And then the very last one would be 12 times 10. So you want to make sure you're multiplying each of your numbers together when you have a box, and multiply it by 2 because there's 2 faces of each kind. And then all we need to do is multiply them all and add them together. 2 times 10 times 6. So I have 120 plus 144 plus 240, which gives me 504. So if I look, 504 millimeters squared would be the surface area. Alright, number 3. For number 3, for this figure here, you did get this one correct, so good job on this one. When we add this area of all of these surfaces here, we do get 1,080 inches squared. So good job on this one. Alright, number 4. So 4, we want to know what is the total surface area of this figure. Remember that trick I just told you. When you have a box, all you need to do is multiply each one of your surfaces together and multiply it by 2. So I would have 2 times 5 times 4, 2 times 4 times 12, and 2 times 5 times 12. Okay, you just want to make sure that you have each number twice, so 4 and 4, 5 and 5, 12 and 12. Whoops. And then we can pop that into a calculator and add them all together. So 120 plus 96 plus 40, which gives me 256. So the surface area of this prism would be 256 feet squared. So 256 feet squared. Alright, so we have a tabletop that Jamie wants to cover, and these are the dimensions of the table. We want to know how many square feet of contact paper does he need to cover the table. Okay, so the tabletop he wants to cover. So again, a tabletop is a rectangle, right? So all we should have to do here is take all of those different surface areas and multiply them all together. And don't forget to also multiply them by 2 because there would be 2 of those surfaces. Okay, so I would take 2 times 3.5 times 3.5, 2 times 3.5 times 0.25, and 2 times 0.25 times 3.5. So let's multiply all these and then add them together. Oops, this should be a 2. Always double check. So 1.75 plus 1.75 plus 24.5 gives me 28. So total surface area he would have to cover with paper would be 28 feet squared. Alright. Let's see, so Alan has a box he needs to paint for an art project, and the box dimensions are 4 by 3 by 2. How much total surface area does Alan need to paint? Alright, cool. So this one is another box, so we can use our trick, where we take each one of our numbers and multiply them together, and multiply it by 2 to account for the 2 sides on each box. So I would have 2 times 4 times 3, 2 times 3 times 2, and then the last one, which would be 2 times 4. And please don't forget to put that 2 in front as well. Oops, 2. And then add them all together. So 16 plus 12 plus 24 gives me 52. So Alan would need to paint 52 square feet. 52 square feet. Alright, number 8. we have another prism and we want to know what is the total surface area. So again, let's take 2 and multiply it by all of our sides. So 2 times 3 times 3, 2 times 3 times 9, and 2 times 9 times 3. And to give you guys an idea of what I'm doing here is I'm kind of going down the line. So I'm doing 3 times 3, and then I'm doing 3 times 9, and then I'm doing 9 times 3. I go all the way back to the top to make sure that I'm covering all my surfaces. So 2 times 3 times 3, 2 times 3 times 9, 2 times 9 times 3. So I have 18 plus 54 plus 54, which gives me 126. So surface area of this rectangular prism will be 126 feet squared. All right, number 8. So it says that here Michael has this cube and we want to know which expression will let him find the surface area of a cube. Well, if you think about what a cube looks like, right? A cube has all the same size sides because it's a cube. It's all the same. So if I were to take x times x and I'd multiply it by 2, and then I would have 2 times x and 2 times x, because it's the same exact process as how we would use these formulas to find surface area of a box or a rectangular prism, except now we have a cube. So if I look here, I have I have 2 times 2 times 2, and if I were to add all of these together, because remember I'm adding these together, I would have 2 plus 2 plus 2, which gives me 6, and then if I look inside each of my parentheses, I am multiplying 2 x's together, which is the same as x squared. So 6x squared is an expression that Michael can use to find the surface area of his cube x. So say his side length was 10, he would do 6 times 10 squared. All right, number 9. So number 9, here we have a large pink box with a small pink cube, and we want to know what is the surface area of the composite figure. Okay, so let's start with that big box. So that big box, I have a 7, 15, and 5. So I'm going to do our little quick method of finding the surface area of this box. Okay, so then let's bring back that calculator and type all this in. Add it all together. So I get 430. So this big box has a surface area of 430. And then that small cube has a side of 3 inches, right? So remember that formula we just did where I would have 6x squared? Well, since my sides here are 3, I'm going to substitute that 3 in for x. So I'd have 6 times 3 squared. And that gives me 54. So we are almost there. When we add these two surface areas together, oops, I'm not typing. So 430 plus 54, I get 484. Oops, I did the thing again. Where I mucked up my paint. I'm just gonna do new. Let me close it and then reopen it. Sorry. I do this all the time when I Alright, here we go. Okay, so I added that 430 with the 54, and that gave me 484. However, if we think about it, this area right here where these two figures meet, that is not a surface, right? I'm not counting that one side of my cube where it's attached, so that means I need to subtract the area from that one side. And since this is a cube, all cubes have the same area. So this front side here is going to have the same area as this back side. So the front area of this cube is 3 and 3, right? So 3 times 3 would give me 9. So I need to subtract 9, which is the area of this back side of my cube that's attached to my box. So then if we were to subtract that 9, I get 475. Let me double check that all my numbers are correct here. Interesting. So the course is saying that the correct answer is 466. So I think I might have accidentally just typed in a number wrong somewhere, or maybe did my adding somewhere incorrectly, but I just can't find it right now. I probably typed in a number wrong somewhere. Alright, I'll come back to it if I can find it. Let's move on to 10. So for 10 here, we have another surface area. And we need to find the surface area of this box in square inches. So notice how when we're looking at the units, we don't all have inches everywhere. Up here we have 0.5 feet, and down here we have 1 foot. So before we start finding the area of each surface, we need to make sure that we are changing all of our units into inches, because that is what our question's asking. So I'm going to try my best to redraw this figure. This up here, 0.5 times 12 would be 6. Let's see how this is working out for me. It's not that bad. It's okay. So this is 10, this is 4, this is 7, and on the bottom 12 times 1 would give me 12, so this is 12 inches. Okay, so let's kind of start going through and finding the surface area of each one of these surfaces. So let's start with this big box up here. Since this bottom side is 10, that means this top side is also 10. So 6 times 10 would give me 60. I'll color coordinate it. So this is 60. Let's start with, then let's do this box here. I would have 10 times 7, which is 70. This box down here. So for this box here, I know that this long side is 12 and this short side is 6. So if I were to do 12 minus 6, I would get 6. So this is 6 inches by 10, because again, this bottom one is 10. So 6 times 10 would give me 60. Let's do this front one here. So 4 times 10 would give me 40. Then let's see, let's do orange next. I'm going to cut this one like this and do this side here, which would be 6 times 7, because again, I'm just bringing these units across my figure. So 6 and 7. So 6 times 7 would give me 42. Let's see, then let's do dark blue to do this bottom one here. Now notice I have 6 and 6, which means that this top side would be 12, just like this bottom side. Here, over here, this long side right here is 4 inches, which means this is 4, so I would have 4 times 12, which would give me 48. So those are all the surfaces that we can clearly see. Now we have to think about the surfaces that are behind it. So this orange side is going to have the same orange side on this opposite end that we just can't see. So I am going to take that 42 surface area that we get, and I'm going to put a multiply it by 2 in front, because I know I'm going to have 2 of those. Same thing with this 48 down here. I'm going to have another one on the back, so I'm going to multiply that by 2. Then let's think about the bottom, the very bottom. The base. So I would have 12 times 10 would give me the area of the base of my figure. So it would be 120. And then the very last surface area we need to do is the very, very back. And for the very, very back, we need to figure out how tall this side is here. And if I look, I would have 7 plus 4, right? 7 plus 4 would give me the height of this very back one. So that is 11. And the length is going to be 10 because I have a 10 down here. So the very last side would be 10 times 11, which would give me 111. So now all I need to do is add all of these together. So I'm going to pop them into my calculator. Okay, so I have 60 plus 70 plus 60 plus 40 plus 84. I multiplied it by 2 in my head. And then this would be plus 96. Again, multiplied it by 2 in my head. Plus 120 plus 110, which gives me 640. So final surface area for this composite figure would be 640. And if you're struggling with seeing each one of the sides, I would maybe get a piece of paper and some colored pencils, re-sketch it like I did here, and then just color code it. Color coding it for me helps me see which sides I haven't done yet, and it also kind of helps me envision the other sides as well. Alright, number 10. Here we have a surface area of a cube. Okay, so remember we have that cube formula that we can use. That is 6x squared, where x is my side length. And my side length for this cube is 5. So I would have 6 times 5 squared. And we can type that into Desmos if you would like. So I have 6 times 5, and if I hit this, where's the little squared? A squared. It does that. Don't forget to multiply it, which would give me 150. So surface area of this cube would be 150 square inches. Alright, next one. So here's our next composite figure. I'm going to do this the same way we did the other one, where I'm going to sketch it as best I can. And hope for the best. Alright. So let's double check our units first. We want to know our answer in square inches. All the units on this figure are in inches, so we are good. And then all we have to do now is just find surface area of each of the sides. So this is 6, which means this is 6. This is 5, which means this is 5. This is 1, which means this is 1. This is 7, which means this is 7, this is 7, and this is 7. Bottom is 11. And since this side here is 5, and this side down here on the bottom, if I do 5 plus 1, that would give me 6 for this very back side here. Okay, so let's do top, right? I have 7 times 6 gives me 42. Let's do this here. 7 times 5, 35. This one here, let's see, we need to do some subtraction. This bottom side is 11 and this top is 6. So 11 minus 6 would give me 5. So I have 5 times 7, which gives me 35 again. This front side, 1 times 7 is 7. For this here, I'm cutting it into 2. So this bottom one here would be 5 times 1, which is 5. What color am I missing? Green. Then this big box here, I would have, let's see, 6 times 5, which gives me 30. And I think that's it for surfaces we can see. Let's look at that back one. That back is going to be 7 times 6. So the back will be 7 times 6, which is 42. I'm also going to have another side of my green, so I'm going to multiply my green times 2. I'm also going to have another side of my red 5 here. Multiply that by 2. And then I think all I need to do is find the base. And base would be this big 11 times 7, which is 77. So now let's add all of them together. 42 plus 35 plus 35 plus 7 plus 10 plus 60. Don't forget to multiply those by 2. See, I get 308. I think I'm missing a side somewhere. Let's see. 5 times 1, there's 2 of those. 5 times 6, there's 2 of those. The base is 77. That back side is 42. Let's see. I'm missing one somewhere. I just don't know where I am missing a side. Let's see. 7 times 5 and 7 times 6. 5 times 7 is 35. And I have 1 times 7. If I cut this, I would have 1 times 5, and there's 2 of those. And then I would have 5 times the 6, which would give me 30. And there are 2 of those. This back side is 6 times 7, which gives me 42. And then the big base would be 11 times 7. So let's see. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Interesting. So I get a different answer than what the course says. The course says that this answer should be 320. So for this answer, type in 320, although I get a different answer. So I'm going to ask a few other math teachers for their input to see if I might have accidentally missed a side. So for this one, put 320. Alright, so for 13, this one with this big, almost like a tent on a base that's yellow, you did get this one correct, and no, he did not add the he didn't find the surface area correctly because he forgot to subtract the area of the faces where the two prisms are attached. So this one with that yellow figure is no, because, etc. Alright, 15. So Sarah has 2 similar rectangular boxes. The dimensions of one box are 4 times those box of 2. How many times greater is the surface area of box 1 than the surface area of box 2? So for this one, I think it's easiest to just plug in some easy numbers for a box. Say box 1 has surface area 1, 2, 3, or those are the sides, and for box 2 it's 4 times bigger, so I need to multiply each one of these by 4, which would give me 4, 8, and 12. So let's just find the surface area of each one of these boxes. So for box 1, I would have 2 times 1 times 2, 2 times 2 times 3, and 2 times 3 times 1. And then for box 2, two times 4 times 8, 2 times 8 times 12, and 2 times 12 times 4. So I'm going to type all these into my Desmos. 2 times 1 times 2, not plus, multiply. So I'd have 4 plus 6, 12 plus 6, which gives me 22. And then I have 2 times 4 times 8, 2 times 8 times 12, and 2 times 12 times 4. So I have 64 plus 192 plus 96, which gives me 352. So to figure out how much bigger this one is, we need to divide them. So 352 divided by 22 gives me 16. So box 2 is 16 times bigger than box 1. So box 2 is 16 times bigger than box 1. And then the very last one, we have these 2 boxes here, and you did get this one correct with the purple boxes. And your answer was no, she did not include the area of the 14 by 20 centimeters, or side of the box. So good job on this one. So no, she forgot this one side, that 14 by 20, on this purple checkpoint here. Purple question on the checkpoint. Perfect. Great. All right, so that is all of checkpoint 27. You are good to submit.